Welcome to the AI Research Roundup. I'm Alex. Today, we are looking at a paper from the Hugging Face trending list, published on August 28, 2025, just 2 days ago. The standout claim is zero-shot 3D visual grounding that ties 3D proposals to multi-view real scene images, and with an iterative visual language model loop, reaches ACC at 0.25 of 55.6% and ACC at 0.5 of 49.6% on ScanRefer. The paper is titled SeqVLM, Proposal-Guided Multi-View Sequences Reasoning via VLM for Zero-Shot 3D Visual Grounding. And as we will see later, the results are really impressive. Beyond the headline numbers, the approach narrows domain gaps, handles occlusion through proposal-guided projections, and shows strong gains on NR3D as well. On X, one post highlights finding objects in 3D scenes using segmentation masks and visual language models over multi-view image sequences, echoing the proposal-guided pipeline and iterative reasoning. Engagement looks healthy with about 170 likes and a few replies, suggesting solid interest from practitioners. Also, the authors shared the official code on GitHub. You'll find a full PyTorch implementation with SeqVLM modules, pre-processing scripts, prompts, configs, and visprog logic. The README walks through conda setup, data prep for ScanRefer and NR3D, model weights, evaluation scripts, and an optional ZSVG 3D fallback, plus requirements and main entry points. Alright, the previous segment covered the code release. Figure 1 contrasts single-view pipelines with the proposal-guided multi-view approach. The top row shows prior methods that render one view and send it to a visual language model, which often misaligns geometry and selects the wrong object. The bottom row adds proposal selection, then projects those candidates into multiple real images, so the visual language model reasons, with consistent context, and picks the correct object. The multi-view stitching preserves spatial relationships and reduces occlusion errors. Okay, the previous figure contrasted single-view baselines with the candidate-driven multi-view idea. Figure 2 shows the full pipeline end-to-end, which matters because each stage trims ambiguity before the visual language model decides. Panel A filters 3D instance proposals using confidence and text similarity. Panel B projects each candidate into multiple real images, selects the largest views, and stitches them as sequences. Panel C slices sequences into batches, so the agent can iteratively pick the best matching proposal and return its 3D box. So the previous figure outlined the pipeline. Table 1 reports comparative results on ScanRefer, split by unique, multiple, and overall. The key takeaway is that the zero-shot variant reaches 55.6% at ACC at 0.25 and 49.6% at ACC at 0.5 overall, which surpasses prior zero-shot baselines by sizable margins. The method also posts 77.3 and 72.7 in the unique subset and 41.3 at ACC at 0.5 for multiple, showing stronger fine-grained localization when distractors exist. So, the previous table covered ScanRefer results. Table 2 summarizes NR3D with splits for easy, hard, view-dependent, and view-independent, so the comparison captures both distractor density and viewpoint sensitivity. SeqVLM leads zero-shot methods at 58.1 easy, 47.4 hard, 51.0 dependent, and 54.5 independent, yielding 53.2 overall. The gains are broad, which suggests the multi-view sequences and iterative selection reduce ambiguity across perspectives, not just in simpler scenes. Alright, the previous table summarized broad gains on NR3D. Figure 4 contrasts inputs to the visual language model, which matters because viewpoint choice decides whether key cues survive. Panel B shows a single rendered view where the chair's wheels and roller base stay hidden, so the description becomes ambiguous. Panel C presents a stitched multi-view sequence that reveals the rollers across frames, making the distinctive feature explicit. Panel A provides the ground truth scene for reference. Wrapping up, 2 takeaways stand out. Proposal-guided multi-view sequences let the visual language model see consistent geometry and context, and the iterative selection keeps compute manageable while boosting zero-shot accuracy on ScanRefer and NR3D. The broader implication is practical 3D grounding without scene-specific training. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.